All right, this is problem number 31. And it's kind of confusing the way they drew it. They drew it as a graph here with the momentum vectors plotted on this Cartesian coordinates. And they say what's really happening is two particles are colliding. But we got to look, this is the initial momentum of particle 1. This is the initial momentum of particle 2. So what's really happening is you have particle 1 here going that direction, particle 2 going in this direction, and they run into each other, okay? And then this is the final momentum of particle 2, so what's going to happen here is mass 2 actually goes and ends up like this. So this is its initial, this is its final, and this is V1 initial. We want to figure out where V1 final is. Where does the particle go, mass 1 go after this collision? And so we have to do this as collisions, okay, momentum conservation, but you notice it's in 2 dimensions. So if it's in 2 dimensions, we have to do it separately. So we're going to do X direction, and we're going to do Y direction separately. So in the X direction, we have the momentum initial from particle 1 plus the momentum initial from particle 2 has to be equal to the momentum final from particle 1 plus the momentum final from particle 2. This is only in the X direction, so really these should have X's on them. Now be careful, we got lots of subscripts here. Okay, now each of these is calibrated, so this is 3 here, this is 2 here, so you can see this is 4 and this is 1 here. So we can just split this into components. So this is the initial right here. This is the initial momentum in the X direction. So this is P1 initial X. This is P1 initial Y. And we can do the same thing with the other ones here. This is going to P2 initial X. This is P2 initial Y. Okay? All right. So P1 initial X, all I care about is the X component. And the X component of this is 3, but it's in a negative direction. So this is going to be negative 3. And for 2 in the X direction, this is going to be positive 4. Right? So I'm looking at this vector here. And then we look at the final. This is what we're trying to find. And in the final, P final 2, it's this direction, which is the Y direction. There's no X component at all. So this has to be equal to 0. I'm sorry, plus P final 1x. Okay, so P final 1x has to be equal to negative 3 plus 4, or just 1. Okay, which is very easy. Now in the Y direction, let's look at it. We got to do the same thing, but this becomes P initial 1 in the Y plus P initial 2 in the Y must be equal to P final 1 in the Y plus P final 2 in the Y direction. So in the Y direction, for particle 1, which is this one here, it has a positive value of 2. And for the particle 2, it has a positive, or a Y value of 1. And then this is what we're trying to solve for. And this has a value of negative 2. So I move this over here, and I'm going to get 2 plus 1, or this is going to be equal to 5. All right, so you can write this. What they wanted you to do was write it in vector. So P1 final in vector notation would be 1 I hat plus 5 j hat is vector notation. Okay? And this is in units of kilogram meters per second. If you wanted to actually figure out the direction, which they didn't ask, but we're going to do it anyway, or the total momentum, well, the total momentum is just going to be equal to 5 squared plus 1 squared. And that's going to be equal to the, so this is momentum 1 final here, square root of 26, which is equal to 5.1 kilogram meter per second. Okay, and you want to know the direction, the angle is going to be equal to the inverse tangent of y over x. In this case, y is 5, x is 1. And you get the inverse tangent of 5 over 1 is 79 degrees above positive x-axis. So we realize that what's going to happen is this one's going to hit here. This is going to bounce off and go this way, so that this angle right here is 79 degrees once it bounces off. Should make that straighter. So this is where V2 final is. All right, that's how you do number 31.